You could graph anything on the face of the earth if you just plotted enough points. So let's go through and let's see where the graph of inverse sine comes from. To begin with, when we say arc sine 1/2 is equal to theta, like we did yesterday, we said by definition that means that sine theta is equal to 1/2, and we're only working between negative pi over 2 and positive pi over 2. So if we generalize that a little bit more, we could say arc sine x is equal to y means that the sine of y is equal to x. Now you can see right there why this is an inverse, because typically we would say the sine of x is equal to y. In an inverse, x and y switch places, right? So that's why we're getting the sine of y is equal to x. Also think about the values that we traditionally would have for the domain of the sine curve, okay? Domain would be all real numbers and range would be from 1 to -1. But look at this. If you'll notice for our x values here, our domain values are going to be from -1 to 1 because if x and y switch places, domain and range switch places. And our y values down here are going to be from negative pi over 2 to positive pi over 2 because of that restriction, again, when we're working with inverse sine. Okay? So if we go through and graph this, if we're looking at this equation, sine y equals x, I know most of the time they'll tell me something like, sine is equal to 1/2, and I have to go back and find y. It's actually a whole lot easier if I can plug in values for y and create the values for x. And so I'm going to come down here and I'm going to use the values between negative pi over 2 and positive pi over 2 that are on my unit circle, that are the values that I know. So I could say like the sine at negative pi over 2 is -1, and the sine at negative pi over 3 is negative square root of 3 over 2, which is negative 0.9. And sine at negative pi over 4 is negative square root of 2 over 2, so negative 0.7, and so forth. And then I'm going to come over and just plot those points. So -1, negative pi over 2, negative 0.9, negative pi over 3, negative 0.7, negative pi over 4, and we can plot each of those values, and that's how we get this curve that you see. Starts over here at -1 and goes over here to +1, and again, that's our domain, and then our range from negative pi over 2 to positive pi over 2. We could do that same process then on page 347 in the middle of the page for cosine and generate the graph that you see there. And then on the bottom of the page for tangent, and you'll see the graph there for arctan. So a great place there on 347 to get all three of your graphs, sine, arc cosine, and arctangent, their domains and their range. Now, one of the other things that we already know about graphing inverses is that when you graph a function and its inverse, it reflects in the line y equals x, right? So you don't have to draw this on yours, but if I went through, remember my sine curve looks like this, right? So if I went through and I put my sine curve on here, and then I drew the line y equals x, sure enough, it does reflect in that line. So that's another way for me to see that they are inverses. All right, so in addition to the graphs of the inverses on 347, the other thing we want to pick up today is compositions of inverse functions over on page 349. We've done compositions of functions before, like f of g of x and g of f of x and that type of thing. So now we want to do a composition of functions where one or of those functions might include an inverse. All right, so look at this first one. We've got the arc sine of the sine of pi over 3. Arc sine of the sine of pi over 3. Ignore the outside function and let's just start inside the parentheses with sine pi over 3. Okay? Sine pi over 3 is a value that we know. We've been using it for a couple of weeks now. We know the sine at pi over 3 is square root of 3 over 2. So now I've got arc sine of square root of 3 over 2, and now I'm right back to the same type of problems we were doing last night, right? We probably did that exact same problem last night, where we said arc sine literally means, by definition, that sine theta is equal to the square root of 3 over 2, and I only have first and fourth quadrants to choose from. I get all that from the definition of arc sine. So then I could look at this and say, okay, I need a reference angle. Where is sine equal to square root of 3 over 2? Well, sine is equal to square root of 3 over 2 at pi over 3, so that would be my reference angle. And then sine is positive in the first and the second quadrant, but second quadrant is not within my restriction for inverse sine, So I'm going to throw second quadrant out the window, cut my work in half, and just give the first quadrant answer, which would be pi over 3. Now, I don't know about you, but I feel like I just ran in a big circle. Like, I started by saying, where is sine to 3 over 2? Well, I started with saying, what's the sine at pi over 3, and got square root of 3 over 2. And then I said, where is sine equal to the square root of 3 over 2, and went back to pi over 3. I did just go in a great big circle. Because when I work with a function and its inverse, they undo each other, right? They cancel each other out. So what I could have done from the very beginning is said, arcsine and sine are inverses of each other. They cancel each other out and just leave me with the x value that I started with. Remember, we proved with compositions of functions that when you're working with inverses, if f of x and g of x are inverses, then f of g of x would just be x, and g of f of x would. So if I do f of g of x, the f and g would cancel each other out and just give me x. Ooh, great, that works every time, right? No. Look at the next one. We have the arcsine of the sine of 2 pi over 3. Ooh, arcsine and sine are inverses of each other. They're going to cancel each other out, and my answer is 2 pi over 3. What's wrong with that? Can you cancel there? Where is 2 pi over 3? What quadrant? Second quadrant. Where is arcsine valid? First and fourth. I can't get an answer in the second quadrant because arcsine doesn't exist in the second quadrant. It only exists in the first and the fourth. So that's my problem. So I can do that fun little cancel thing if I am within the designated parameters for the problem. So for arcsine, if I'm in first and fourth, I can cancel. Arccosine, if I'm in first and second, I can cancel. Arctangent, if I'm in first and fourth, I can cancel. But otherwise, I can't. Okay, what am I supposed to do if I can't cancel? Then I go back and do it the exact same way I did that first problem, right? I go back and ignore this arcsine on the outside. Let's just work on the inside with sine 2 pi over 3. All right? To find the sine of 2 pi over 3, we've been doing this since section 4.4, but just a reminder, I'm going to go through and say, okay, I need a reference angle. It's got a pi over 3 in it, so that will be my reference angle. So I find the sine of that reference angle. So the sine at root of 3 over 2. Then step number 2, I have to figure out whether it's positive or negative based on the quadrant that it's in. We've already established it's in the second quadrant, so all students' sine in the second quadrant is positive. So I'm going to get a positive of the sine of the reference angle. I'm going to get a positive square root of 3 over 2. Okay, so again, that's way back from section 4.4. Now, I'm ready to do the problem, the arcsine of the square root of 3 over 2. And you'll notice that's the exact same thing I had over here a second ago. So I'm going to go through and say that means that sine is equal to the square root of 3 over 2, and I only have first and fourth to choose from. I can find my reference angle is pi over 3. And then because normally I would give both the first and the second quadrant angles, but because arcsine is only valid in first and fourth, I can throw my second quadrant out the window and just keep my first quadrant answer, which is pi over 3. All right, so look at the next one. I have the tangent of the arctangent of negative 5. Can I cancel? How do I know? Where does negative 5 have to be? First or fourth, right? Because the region for arctan is first and fourth. So I got to figure out where negative 5 is. Negative 5 is not between 0 and 2 pi, right? 6.28. It's negative. I don't know where that is. So remember we've said if you don't like the name of something, you can change it by finding a coterminal, right? So I'm going to find the coterminal for this by adding 2 pi. So I'm going to go through and I'm going to take my negative 5 and I'm going to find the coterminal by adding 2 pi. So I'm going to add 6.28 and I get 1.28. So when they said the tangent of the arctangent of negative 5, it's the same thing as if they had said the tangent of the arctangent of 1.28. Now we just have to figure out where 1.28 is. If this is 0 and this is 1.57, then 1.28 has to be in the first quadrant. So can I cancel? Yes, right. Because it is within the designated region of first or fourth, then yes, I can cancel. Now, you could say that your answer is -5, or you could say that your answer is 1.28. In the book, they say -5. The better answer is probably 1.28 because it's between -π/2 and +π/2, but either one would be fine. All right, look at the next one. For the next one, they give me the tangent of the arc cosine of 2/3. Can I cancel and just say my answer is 2/3? Why no? Yeah, they're not even inverses, right? I can cancel tangent with arctangent, or sine with arcsine, or cosine with arccosine, but I can't cancel tangent with arccosine, right? So let's start with the inside piece, what's in parentheses, okay? Inside parentheses, I have arc cosine of 2/3, which by definition means cosine equals 2/3, and I only have first and second to choose from. I get all of that from the definition of arc cosine, all right? And once I've gotten that established, then I'm going to take the tangent of that, okay? But let's start on that inside. If I'm thinking about where is cosine equal to 2/3, that's not a value on the unit circle, right? However, if I think about square root of 3 over 2, square root of 2 over 2, 1, 1/2, 0, I don't have a 2/3. So if I can't use a circle, then I can go back to using triangles like we've done before, right? So I'm going to build a right triangle, and I'm going to choose one of the acute angles. It doesn't matter which one you choose. I chose the angle down here. So I'm going to say cosine is adjacent to over hypotenuse 3. How am I going to find the other side? Pythagorean theorem, right. So I could go through, and I could say 2 squared plus some unknown side b squared, is equal to the hypotenuse 3 squared. So I'll go through and subtract 4 from both sides, and I'll get b is plus or minus the square root of 5. I don't know if it's positive or negative. It depends on the quadrant I'm in. So let's go back and figure out our quadrant. I know that I'm either in the first or the second quadrant because I had arc cosine, and that's the only place that it exists. Remember that cosine is positive in the first and negative in the second. So since this was a positive 2/3, I have to be in the first quadrant. If I'm in the first quadrant, then I know b is going to be a positive square root of 5, not a negative, because everything's positive in the first quadrant. So from that inside piece of information, I have to get two things. I have to get the triangle values, and I have to get the quadrant that I'm in. From that inside piece of information, I have to get two things. I have to get the triangle values, so I have 2, 3, square root of 5, and I have to get what quadrant I'm in. Okay, I'm in the first. Now I'm ready to answer the question that was asked. The question that they asked me was, what is the tangent based on that information? So I'm going to go back over to my triangle and say, okay, what's tangent? Well, tangent is opposite square root of 5 over adjacent 2. And because I'm in the first quadrant, everything's positive, so I know the tangent will be a positive square root of 5 over 2.